Here are some more molar calculations that deal with the combustion of hydrogen with oxygen to make water. So I've put the balanced chemical equation here. Now we already solved this problem, so let's go ahead and move on to these three. How many grams of each reactant were used? I'll solve it in my head first, then show you mathematically. I used 3 moles of hydrogen, and by the way, reactants are on the left side of the arrow. 3 moles of hydrogen, it's bimolecular, it's H2, and each hydrogen checks in at 1 gram per mole. So we have 3 moles at 2 grams per mole for the molecule. That means we have 6 grams. We got 1 mole of oxygen, and that's O2, and that will check in at 32 grams per mole. So that's the gram amounts is 6 grams and 32 grams. How many moles of water were formed? Well, it does say collected. I'm going to assume that collected and formed are essentially the same thing. And we got 1 gram of water. However, 18 grams is a mole, so we only got 1/18 of a mole. And there's the calculation with canceled units. 1 gram of water, where 18 grams of water is a mole. Notice that grams of water cancels, and we get 0.06 moles of H2O. I only used 1 sig fig there since that's what they started with. Now, what's the theoretical yield in moles and grams of water? Well, theoretically, you need 2 for every 1, but we are given 3 for every 1, meaning we have an excess of the hydrogen. So with the limiting reactant is oxygen, you'll run out of oxygen first. That's as much as you can form. And a mole of oxygen gives you 2 moles of water. So that would be our theoretical yield in moles. It's 2 moles of water. Since each mole checks in at 18 grams per mole, it should be 36 grams of water. So here it is shown mathematically. It's just a 1-to-1 conversion. 1 mole of oxygen gives you 1 mole of water. And that would be 18 grams for our theoretical yield. So that's a few more solved problems dealing with the combustion of hydrogen.